It is hard to wrap your head around just how much concrete we use as a species. It is the most consumed human-made material in the world and second only to water in total consumption. In the time it takes me to say this, 19,000 bathtubs worth of concrete will have been poured by the global construction industry. Concrete is everywhere. If you're in a building of just about any kind, you're probably on a foundation of concrete right now. And it's also responsible for considerable greenhouse gas emissions. The emissions from concrete manufacturing globally are more than the total emissions from almost every entire country in the world, except for the United States and China. But what if concrete could be part of the solution? What if it could do more than help us make roads and bridges and buildings? What if all that material could be a place to store emissions that would otherwise end up in the atmosphere? Today, we're talking with Rob Niven, the CEO of CarbonCure, about the future of concrete, carbon utilization, and how we build. Here on Carbon Copy. Thanks for joining us, Rob. I must say, I love the name of your company, CarbonCure. So let me start with a hardball question. Do you have the cure for our carbon problem?
We have a cure for the carbon problem, specifically a cure for the carbon problem aligned with the built environment and the concrete that's used to build the world around us. CarbonCure is really a double meaning to it. Not only is it a cure for climate, but it's also a type of curing reaction, which is a technical term used in the concrete industry for strength development, is when the concrete cures. It's how it develops higher strength, which is one of the other features of this technology.
Very clever. So it's one tool in the toolkit, but an important one. What is your tool then? What does CarbonCure do?
So we look at carbon dioxide a little bit differently than most people. We see CO2 as a feedstock to make concrete, and concrete that has a lower carbon footprint with some cost efficiencies and higher strength. And of course, we recognize the climate urgency and how we need to reduce the amount of CO2 going to the atmosphere. But we definitely think that we need to start looking at opportunities on how we can productively and profitably use that CO2, such as in the production of concrete. So what we do at CarbonCure is we integrate the consumption and the permanent consumption of CO2 in the concrete manufacturing process. It's about a one-day retrofit that we can work with any concrete plant in the world, where the CO2 is then added and reacted with to form a mineral in the concrete, which provides additional strength, cost efficiencies, and a lower carbon footprint. The technology has really taken off over the last couple of years, and maybe that's coincidental, but it was around the same time that we got connected with ERA and started working in Alberta. But it's now been adopted in over 300 plants, over 3 different continents, and soon entering into a 4th. And most of that growth was occurring during COVID. So we can't wait to get into 2021, where we can look at COVID in the rearview mirror, hopefully, and be able to even perform at an even higher rate.
Let me drill down a bit. How does that work? You mix carbon dioxide in the concrete curing process. What happens to it? Where does it go?
Great question. Some of the audience or yourself might be familiar with cement manufacturing. And in cement manufacturing, you take a limestone or a carbonate mineral and you heat that at high temperatures for it to break into 2 parts. So the actual limestone is broken into 1 part CO2, 1 part clinker or calcium oxide, which is a precursor to make cement. And cement is the reactive ingredient in concrete. It's the gray powder. What we're doing is, in a way, reversing that reaction. So if you were to go take a drive and see some of the cement plants, whether in Edmonton or on the way to Banff, you'll see these large cement plants. And in a way that we're reversing that reaction in concrete facilities. So by adding carbon dioxide back into contact with cement and concrete as it's being cast, you have a reverse reaction which is occurring. What I mean by that is the CO2 is rebinding with the calcium ions to form a calcium carbonate. And then that's turning into a mineral. So it's precipitating as a mineral inside of concrete that creates all this very fine material in concrete, which then allows the normal reaction of cement curing to occur much more effectively. And that's what gives concrete higher strength and then presents opportunities to be able to optimize the concrete mix by using less cement to provide concrete of equivalent or better performance.
Now, as you know, we all know there's carbon dioxide all around us in the atmosphere. Why do you need to mix it in? Can't the concrete mixture get carbon dioxide from the atmosphere while it's curing?
Yeah, those are two entirely separate chemical reactions. What you're referring to is something called weathering, and that can actually have a harmful effect on the durability of concrete. That's one of the main reasons on why you see portions of overpasses cracking and sometimes failing. It's where the CO2 is getting into concrete, changing the pH and causing the rebar to actually expand as it corrodes. That's a negative thing. What we're doing is called early carbonation, and a different chemical reaction occurs inside concrete, which is very defined, which creates this nanomaterial that leads to the higher strength. So it has an entirely different effect. So yes, concrete does react with CO2 in the atmosphere, but you actually are designing concrete to minimize that, to avoid some of those durability issues. What we're doing has no impact on pH and actually improves the quality of concrete and provides that CO2 benefit at the same time, as well as some cost efficiencies.
Okay, that's how it works from a scientific perspective, but help me understand how it works from a practical perspective. I'm picturing what we typically call a cement truck, where the back of the truck spins around to mix the cement with the water and the aggregate to form concrete. Do you just inject CO2 into the rotating drum on the back of a cement truck?
Sure. We do add the CO2 at the batch plant. So there are thousands of batch plants across Canada and hundreds across Alberta. And they're all about the same. There's two different kinds, but all of the CO2 injection occurs as all of the ingredients of concrete are being loaded into the truck. And it can be pre-mixed or it can be mixed inside the truck, but it all happens at one stationary location on where the actual product is made. And then it's loaded into a truck and sent to the job site. But that whole transit period, and then as it's being poured on site, the reaction is already underway. It's been done at the plant and it's already completed. This reaction is very, very quick, and it has long-lasting impacts, though, where it does continue to improve the strength of concrete well after the reaction has been completed.
How much of the CO2 that you put into the mixture actually ends up in the final concrete?
There's two ways to look at that. So one is from an efficiency of mineralization, and then secondly, for like how much is actually consumed. So from an efficiency perspective, we're talking very high efficiencies of CO2 that's turned back into a mineral in the 90 plus percentile rate of use. So this would be CO2 that would normally all be released to the atmosphere, because we source our CO2 from large final emitters. And I think in the case of most plants in Alberta, it would be collected from the Fort Saskatchewan Dow petrochemical complex. And then the other side is how much CO2 do we add? Well, we add a small amount of CO2 by weight of concrete to be able to initiate this chemical reaction. Most of the CO2 overall reductions actually happen from efficiencies gained from using less cement and concrete. This is actually a really important question, Mark, because CO2 is actually very expensive to purchase. It's funny, but to get CO2 in the market today, it's readily available and commonly used for food and beverage, like sparkling water, or beer, or soda. It's the same CO2, but it's a pretty high cost. So we had to find a business model that maximized the CO2 reduction, but minimized the cost so that we could have an economic incentive to adopt this technology. So in doing that, we had to minimize the CO2 injection and mineralization to get the maximum benefit in the product. As we look at our portfolio of technologies that we're bringing into the market now, we're then now able to expand and introduce new technologies, like the one that was just deployed for the first time in the world in Alberta and Calgary for the Carbon X Prize, that consumes multiples more of CO2, but still provides that economic incentive to be able to provide economic benefits for the concrete producer. So we'll continue to innovate by creating technologies which have more and more CO2 consumption. But we have to recognize that those will always be challenged by the economics because CO2 is so expensive. And we definitely look forward to a day when CO2 will be even lower cost, or maybe people will even be paying for it to get rid of it. But today it's well over $200 a ton. So it's pretty hard to make economics work with that kind of price point.
How clean does the CO2 need to be? You talked about CO2 for food and beverages. I can only imagine that must be ultra clean. Is it similar for your process, or could you potentially get carbon dioxide from an industrial operation anywhere in the province of Alberta?
It's the latter, but it's just hard to get access to other qualities of CO2. You have to remember, like with our company, we're driven by a mission to reduce 500 megatons of CO2 annually by 2030. So for us, there's a lot of everything that we do is about speed. And we borrow a lot of lessons from the tech industry. It's probably no surprise that Amazon and Microsoft are large investors in our company, as well as Bill Gates through BEV. So a lot of it is speed. And why I bring that up in this question mark is that today's CO2 that's food grade is readily available. We can have it delivered to any doorstep in just a day's notice. So that allows us to move very, very quickly and allows us to scale up so fast, where today I think CarbonCure would represent 95% of carbon utilization deployments worldwide. That's all about speed. Now is, I think, the time for us to reflect upon this model. And with this kind of growth is be able then to look at how can we change the model by looking at lower purity sources of CO2, which of course have the advantage in more sources and ideally lower costs. But we have to make sure that reliability is the most important quality. Is we have to make sure that the concrete producer is relying on CO2 like they're relying on cement and aggregate to be there day in, day out. Is that has to be the priority. And ideally, if we were to make a switch, it would have to be at a lower cost.
So looking at reliability from maybe a different perspective, as we all know, concrete is everywhere, but notably it's used in bridges and buildings and other varieties of critical human infrastructure. Is CarbonCure concrete just as strong, just as safe, and will it last just as long as the concrete we see all around us?
Yes, and at least. We're already pouring concrete into just about any type of project that you can imagine. And including if you take a flight at the Calgary International Airport, that plane will likely be passing over some CarbonCure concrete on the de-icing pads right now. So there's certainly no limitation on the type of concrete that it can be used for. This, I think, touches on a really important topic of scalability. Is when you're developing low carbon solutions, not only do they have to be economic, but they have to actually have a large enough addressable market. So it's really not interesting for us, and we're not going to meet our mission if we're going to provide a technology that can only be used on, ornamental concrete pavers in your garden. That's not going to change the world, and that's really what we're trying to do. So we're really looking to have an effect on 100% of the concrete being used. And you said, obviously it's used everywhere. Most people don't even understand that. Like, this is by far the most abundant man-made material on the planet, second only to drinking water. Like, it's as common as the air we breathe. It's all around us, but most people don't even give it a second thought or notice it in the first place. But where you have industries that are this massive is it also creates a wonderful opportunity to make a big impact. It's an industry that is ripe for change, that's looking for change, and you can really reduce a tremendous amount of CO2.
So give me a sense of scale here. How big of an issue is the emissions footprint from concrete production, and how much can CarbonCure's technology help to reduce this footprint?
Well, I read earlier this year that if the cement industry were a country, its CO2 emissions would be third after China, the U.S. Then you would see concrete. So it's the largest industrial emission source of CO2. And I should say cement, not concrete. You have to distinguish the two. Cement, though, is the critical ingredient in concrete. So very large industry, very large emission profile, accounts for about 7 or 8% of total greenhouse gas emissions. So big problem. And CarbonCure, though, is able, we have a plan to reduce 500 megatons of CO2 emissions by 2030. We think there's also ways that we can exceed that through some new technology that are both in hardware and in the digital AI space. So we're still early on our journey about creating more and more technologies. But just with what we have today, is we can have a very meaningful impact. And what I'm awfully proud of is that's technologies that integrate with existing infrastructure and regulations and provide economic incentives for concrete producers, so that we're not just asking them to throw it in an entire industry and replace it with something new, which in my mind is maybe not realistic, especially not within the timelines that we need to act on climate, which is really 10 years. So we have to find ways that we work with industry to make it more prosperous and more sustainable.
Well, let's talk about what's happening right now then on the ground here in Alberta. I understand that your team was one of 2 winners in ERA's Grand Challenge for CO2 utilization. Tell me about the project that you're currently undertaking in Alberta with funding from ERA.
Yeah, that's right. Very proud to be a co-winner in that process, and it brought forward. Definitely, it was wonderful to win, but also brought a lot of recognition and new partners. So what we're doing right now in Alberta is deploying technology across the province to be able to transform the local concrete industry, to use CO2 and become more sustainable and more competitive. It's also allowing us to be able to accelerate the deployment of new technologies, such as the reclaimed water carbonation process that I discussed earlier, and other things that we're doing in digital and hardware. And also look at how we can create circular economy solutions, first of a kind in the world, where we can be taking the CO2 from other large emitters, non-traditional emitters, and then plug that into the concrete industry so that we can create value from that and create a large circular economy solution, which is also low carbon, to be able to help cities and critical infrastructure scale to a more sustainable manner.
You've had commercial success now in Alberta, elsewhere in Canada, south of the border.
Overseas.
Overseas, yes. What's next after this project with ERA? Can you keep making the process better? Is it now simply a matter of rolling this out across the globe? What more can be done?
I look at the future in 2 pillars. One is, and it all comes back to our mission. I'll keep saying it over and over. So 500 megatons annually by 2030. That's going to take a lot of deployment. So we need to not only figure out how to deploy this technology in Alberta, but how to adapt the technology as it may be required to enter into some emerging markets. Alberta is a very important strategic market, but it's just a drop in the bucket for the amount of volume of concrete that's being poured worldwide. And most of the concrete's being poured where most of the population growth is occurring. And that takes us to some markets that are a little more challenging. So we need to be able to take the lessons that we've learned from both business model and technology in Alberta, and to be able to take that into some new markets. And I'm pretty excited about some of the new areas that we're entering into, like in Southeast Asia, East Asia. South America has actually been a lot of demand. We've been putting plants in recently in places like Chile and Bolivia. lots and lots of learning that's built upon the success that we've had in Alberta. So that's one pillar. We also recognize that even if we were successful with just this technology today, is that we would be leaving a lot of CO2 emissions on the table, if you will. So we've taken this world-leading scientific understanding that we've gained from how to harness the benefits of CO2 and apply that into other points of the value chain so that CO2 can be consumed profitably and productively to make concrete more competitive and greener. So that's going to be another element on the side of continued innovation that applies to existing technology today, where my engineers are just continuing to amaze me about how they can make the process smaller and cheaper and more powerful, just like microchips, but also entirely new approaches on how we can find ways to create value from CO2.
How much is an outdated facility costing you? Whether you're upgrading your equipment, your building, or finding an alternate power source, the upgrades you do now will lead to long-term savings. With the Energy Savings for Business program, Emissions Reduction Alberta is investing $55 million to keep Alberta's small and medium-sized businesses competitive. ERA will cover up to $250,000 per project that lower your costs and lower your emissions. In a province where skilled trades have the local expertise needed to complete these upgrades, it's an investment in your business and our province. Energy efficiency means more jobs, lower overhead, and a better Alberta for all of us. Find out more about the Energy Savings for Business program at eralberta.ca. Can you tell me about the importance of partnerships and collaboration in your journey from where you began to where you are today and going forward?
Yeah, I think about, there's a quote that someone said last year to me, another clean tech CEO, and said that you can only move as fast as you can build trust. And I do believe that, like, we're trying to change how things are done, and we're trying not to do it in too disruptive of a manner, but it's different than the status quo. And you need to build trust across both incumbent industries and other innovators and other partners like government and finance and so on. So that really starts with mission alignment. I feel like starting with that common set of beliefs and vision of the future is a way that you can fast track that. And it's a good starting point to be able to build a very mutually beneficial partnership. And it can be commercial, or it can be with civil society or government. But today, that's one of the first things I look for. Is I just don't have the time or really the inclination to work with groups that don't share the same mission alignment. If that's the case, then I'll move on to the next, and just that's really where we're actually going to get things done. And there's so much opportunity in this space. And if I have to start off the conversation by saying, like really fundamental stuff, or explaining a difference of opinion on acting on CO2 can actually be good for business. Like if we're not there, then there's hundreds of others that we can sort of turn attention to and work with next.
So you talked about your aspirational goal. What conditions for success are going to be needed here in Alberta, around the world, in order to reach that goal?
So technologies like ours, and there are many others, just even in the CO2 utilization or what might be called carbon removal space, we're going to all have our growth trajectory, and you can call that organic. It's fueled by things like investment and talent and breakthroughs in technology. That has a certain rate of deployment. To be honest with you, it's not going to be fast enough to get the job done. Like if we want to be able to avoid a 2 degree or even a 1.5 degrees Celsius scenario, which is, I think, what we all need to be building our models and our business plans off of. It's going to take some other levers, some other ways that we can scale these solutions up. Of course, it always has to be good for business, and we always have to be looking for those mutual win-wins, but there are some things that can be done that are just smart. Two things that I've noticed recently that have been having a big impact is one is in the area of carbon finance. I'm seeing a lot of corporations that are making net zero commitments. The way to be able to achieve that is through the use of high quality, and I'll say that again, high quality offsets. So not some of the junk offsets that have been plaguing this space in the past. Being able to use that to be able to fuel growth and low carbon solutions so that they can be used to offset emissions from certain corporate activities. That's one space that can really accelerate growth. Although another area that I've been really excited about recently is in the form of procurement policy that goes hand in hand with regulatory reform. We're seeing this happen quite a lot right now in the United States, and there's lots of discussions that are starting to bubble up in Canada as well. Believe it or not, the state of Hawaii and the city of Honolulu was the first to lead on this as far as we're concerned. And they took a really common sense, and I think this would really resonate with most listeners in Alberta, approach to procurement. And they said, we'll procure concrete for government projects if it's the same price, same quality, but it's made with CO2 and has a lower carbon footprint. So there's no downside to this. It's just sending a very clear market signal to say, this is where we want to go. We'll leave it to business to figure out how to do that best. And the one that provides the most appealing product without discriminating on price and quality is going to get the business. That really matters because about 40% of concrete is being purchased for government projects. So when you can provide that kind of procurement influence, that really has a strong impact. And we all know what governments are having to go through right now to respond to COVID. There's no extra dollars. But it doesn't mean that you can't also take action on climate. And this is the kind of common sense approach that can be applied by just using your existing procurement, and you're going to continue to be purchasing concrete. You might as well be sending that market signal, because otherwise you're leaving a lot of potential innovation and decarbonization that's available at no cost or very, very marginal cost, really untapped. The most advanced model in this one is called the LECLA policy, the Low Embodied Carbon Concrete Leadership Act out of New York State. This is a really refined procurement model that I know that the federal administration and now more and more states is looking at adopting as a no-lose, scalable solution for decarbonizing the built environment, focused primarily on concrete, which is the largest contributor to the embodied CO2 of most buildings and certainly all infrastructure.
Is there anything I didn't ask about that you'd want our listeners to know?
So there are some things I think that are worthwhile for listeners to know, and one of them is the Carbon X Prize. Alberta just hosted a really world-class competition, and that just wrapped up in Calgary for the Carbon X Prize, which was a global competition for technology entrepreneurs to create the most scalable CO2 utilization technologies. It was being run at the power plant facilities in Calgary that then provided the ability for these technologies to be tested side by side to see which technologies were most scalable for turning CO2 into concrete. So that was pretty awesome. I'd have to say that Alberta has actually been a world leader in supporting the innovation in this space. That's going to be critically required by all other industries and jurisdictions worldwide. And I think that it's really noteworthy to see how Alberta has driven this area of innovation and decarbonization probably more than any other government that we've ever been in contact with. So I think that's definitely should be noted. It's pretty impressive on what's happening here. Most people probably don't know about it. Now we need to turn our attention from innovation to deployment. And I think that's where things like the procurement model type policy, thinking about removing prescriptive standards so that we're not tying the arms behind their backs for concrete producers to be able to bring the best technologies forward. It should be performance-based standards. I think that's an opportunity now for Alberta to really lead on deployment and take advantage of these technologies that can help to decarbonize the economy and create some great thriving businesses. So we're halfway there. we've done the hard part, which is the innovation, but we got to finish the job and look at deploying across the economy to really bear fruit for all this hard work that's been done to date.
Thank you very much, Rob. It's been a pleasure speaking with you.
Thanks very much.